So this is one from section 9.3. It's about proportions, but this is more about finding the p-value and everything. So I'm seeing that they've done some study. They said that there's been some decrease to 9.9% illegal drug use by teenagers. So, and then the principal's gone out and done a sample, random sample, and of that many students, 98 reported use of illegal drugs. We want to test the principal's claim that illegal drug use in her school is below the national average. Well, the national average is 9.9%. So we're going to say for HO that the proportion of teens using drugs in her school is the same as the national average. Okay, so 9.9%. And then we'll test the principal's claim that in her school it's less than the national average. Okay, so that's the HO and H1 or HA. And then we're going to do a z-score. And in order to get that z-score, we're going to do a couple things first. They're telling us that the national average is 9.9%. And we're trying to see if the sample result of 98 divided by 1050, which is our p-hat, that's our sample proportion. I calculated that is 9.3% or 0.093. It's probably enough decimal places. And now the standard deviation with the sampling distribution assumes that the 9.9% figure is correct. So that's what we're going to use to get the standard deviation. So the standard deviation with this sampling distribution is we're going to use that p times 1 minus p over n. That's the formula we're using. So for this one, we're going to use, let's see, so 0.099 times 1 minus 0.099 over 1050. I'm going to take the square root of that answer. So when I do that calculation, I'm getting 0.0092169, etc. You're better off carrying this stuff with on your calculator if you can. Okay, don't round till the end. And that's what I'm going to do. So if I'm going to calculate this on my calculator. If I get slightly different numbers than what you're getting, that's why. So we know that the sample proportion was 0.093, and the old supposed center is 0.099. So what we're going to calculate now is how many standard deviations this 0.093 figure is away from the old center of 0.099. So when I do the z-score for this, I'm getting negative 0.65. And since that normal curve table only carries 2 decimal places, that's safe to round now. So now, what we're trying to do, and if you go back, and this is where it comes into getting the p-value, because our HA, or our alternative hypothesis, we're trying to see if this is how often, what's the probability of getting a sample this low or lower when that old sample, or from that old population proportion. So what we're going to do is we're going to use that number right off the table. So we're going to look up that z-score on the table, and the value it gives us is going to be our p-value. And that'll happen anytime H1 is a less than. Okay? So if I'm looking this up right on the table, I'm getting that probability of getting this far below it is 0.2578, which is not even close to being a rare event. That's saying that 25, almost 26% of the time we'll get a sample this low if this is the true average. So we can't, and mathematically would say we can't reject HO, which means the principal's claim that her school is below the current average probably isn't true. Okay, she just got a good sample that showed it was lower, and it's not statistically significant. So I chose this to do this problem because, and this is from 9.3, because of the type of H1 or HA it is. So they went out and did a sample of people somebody running for an election, and they will want to test the claim that the majority of voters support the candidate. Well, if the majority of voters support the candidate, that's going to be more than 50%. So we'll do HO and say, no, they don't have the majority. HA will be, yes, they do have the majority. So in that case, we'll use in 0.5 for that P-naught, that null hypothesis thing. So our P-hat value is coming from the sample. This is 205 out of 400, which is, let's see, so I got 0.5125. Looks like a slight majority. Let's see if it's far enough above that 50% mark to see if they can if they can declare the election. So we're going to use 0.5. Now we know that 0.5 is the center of this distribution, or we think it is. We want to say if this says that 50% of the voters support this candidate, they want to get more than 50% to win. So that since the 50% is the center, we're going to use that same formula, 0.5 times 1 minus 0.5 over 400, and take the square root. So let's see, that's 0.25 divided by 400, and we take the square root of that. So I'm getting a standard deviation of 0.025. And then I'm going to take the P-hat value and subtract that center value, 0.5, and this is going to be our test statistic, our z-score. This is giving me a z-score of 0.5. So if I go into the table, look up 0.50, the value to the left is, see, because the table always tells me to the left, and if I've got a z-score of 0.5 standard deviations above the mean, it's telling me 0.6915. 0.6915 to find this area to the right, because that's our tail. That's what we're looking for, because we said HO is a greater than. So I'm going to do 1 minus that amount. So 1 minus 0.6915 gives me 0.3085. So is that a small enough chance or a rare enough event to say that the candidate has a majority? Well, this tells me that I've got almost a 31% chance of getting a sample of 400 people where 205 of them support this candidate. So that's a 30% chance of this happening is very likely. So the candidate can't say that they've got the majority yet. They need to wait. Okay. So this problem from section 9.3, they're telling us that according to the Energy Information Administration, that 53% of households nationwide used natural gas for heating back in 97. Then a current survey showed that 54%. We're trying to show that the rates change. Now, what's important about it, even though the sample showed that it's a percentage that's higher than the old percentage, we're going to make this be a not equal to, because they aren't asking us to show that it's increased. They're just asking us to show that it's changed. It might be that it could have decreased, and we just don't know based on the sample. So our HA or HO is going to be, yep, the old proportion is the same. The proportion of people that are using natural gas is the same now as it was then. And then we're trying to test if it's changed. So we're going to do a not equal to. This is a two-tailed test. This affects how we find the p-value. So since we need to do a, let's see, we know that this 54% is p hat. That came from the sample. And we're trying to see if it's far enough away from this middle to say something's going on. So since we're assuming that 0.53 is the middle of this distribution, that's what we're going to use to calculate the standard deviation. So 0.53 times 1 minus 0.53 over how many households? 3,600. So that's the standard deviation we're going to use, and I'll calculate it. So when I do this, I'm getting 0.0081. It's the 83. That's not. Let me change it. 83183 yada yada yada. So I'm going to let my calculator carry that number. So now we're going to calculate the z-score for this, the test statistic. Now the p-hat number, the new sample yielded a 54% rate. We're going to count how many standard deviations away from the old 53% rate is. And I'm going to divide that difference by the 0.0083 number. And of course I'm going to let my calculator carry that. So when I do this, I'm getting a z-score of 1.202. Our table goes 2 decimal places, so I'm going to look up 1.20. So if I go to the table and look the number up in the table, that z-score up in the table, let's see, 2.0. I'm getting an area to the left of 0.8849. And we want this tail area, so I'm going to subtract that from 1. So I'm getting 0.1151. Now, I'm not sure if you've seen this in the book. I want you to notice that when you're trying to find a right tail area, if you look up negative 1.20, you're going to get that number and you won't have to do any subtraction. Okay, because the table tells you the area to the left. Where this is helpful, especially with this problem, is since this is a two-tailed test, we said it's not equal to, we need to double that table value. We need to find those two tails because we don't know whether it's greater than or less than, so we got to account for both those areas. So the p-value for this problem is going to be 2 times 0.1151. So I'm getting a p-value of 0.2302. Which again is a very large p-value, especially at the 5% level of significance. This is much bigger than 5%. So we can't reject HO. Looks like the percentage of people using, a percentage of households using natural gas has not changed since 1997.